It's movie time. Get out your popcorn. Okay, so what I'm going to do is go through your solutions and talk about how I did them. Now, the key to remember is it's not just putting in the R code. I mean, that's good, but you also have to put together the tests of hypotheses. Don't neglect that, because I've had people turn in tests that were just the solution or just the R code, and I had to mark off for that. Similarly, I've had people that just turned in the test hypotheses, but no code, and I had to mark off for that. So you need to have both. Real important, okay? All right. So problem 1, we're looking at GPA. Let me scoot this over a little bit, if it'll let me. As a function of their ACT scores. And we take 120 students, get their ACT score, which is the X, and the GPA. And this is in the GPA 1. So, sorry. So you're going to, sorry, bring the data in, and I'm going to have GPA is equal to, or assigned, my fault, read.table, and I'll show you, I don't know if you know this or not, you probably do. My other class showed me this really cool thing. File choose, comma, header equals true, nuts. The nuts is optional. And I want GPA1.txt. There it is. Okay. And I want to see what it looks like. And it's just a data frame with 2 variables, which I knew it was going to be. Nothing very interesting. And this is a nice simple question. I'm going to set up a GPA.lm, and you're going to have lm of y tilde x, and data equals GPA, poof, and you're going to have summary of GPA.lm. Okay, so what is the least squares regression equation? And I'm going to use a comment. The least squares regression equation is y hat equals, so you're going to have the intercept of 2.114 plus 0.03883x. Okay, I'm just going down the coefficients here. Nothing very dramatic. Okay. If the ACT score is 20, what do we expect the GPA to be? All right, so when you think about this, the y hat is really the expected value for a particular value of x. Okay, expected value. So I'm going to use my predict command. I'll use my GPA.lm, and I will use new data equals data.frame x equals 20. Now remember to call it x because it's looking for the same name, and we expect it to be 2.89. Okay, pretty good. So that's problem 1. Everybody like that? Good. That was fun. Now let's get out our copiers. Okay. And we want to look at the number of minutes of copiers as a function of the number of service calls. The X is the number of service calls, and the Y is the number of minutes. The data are in the file copier.txt. If I were going to feel really funny, I would say that again. Please do the following, read table, header equal true. Sorry. So, I'm going to say copier assigns read.table file.choose open paren, close paren, comma, header equals capital true, and I am looking for copier.text. There it is. Okay. So, I'm going to have cop.lm, and that's going to be lm of y tilde x data equals copier. And let's look at summary of cop.lm. And the least squares equation is going to be y hat equal minus 0.5802 plus 15.03502x. Yeah. Okay. Now, we like pictures, we do. And I want to draw the original scatter plot. And then I want to superimpose the least squares regression equation on that scatter plot. So you're saying to yourself, how am I going to do that? Well, it's really pretty simple. You're going to use copier $x, copier really pretty simple as it takes me 20 times. And I'm not going to dress it up or anything. So that's what the original code looks like. And this is just a basic scatter plot. Okay? So you look at that and you think, oh, that looks pretty good. And then to put the line on, you're just going to use a function called AB line. And you're going to use the function, or I should say the object, the LM object. And before you can say miniature schnauzer, you have it. Okay? Not pretty? Good. And then you can save your file. That's what I did. If you have the Mac, like most of you do, click on the side where the graph is. And if you save it, if you do the save as, it will save it to a PDF file. So you just put whatever name you want to call it and put where you want to save it. Okay? All right. Now, test beta 1 equals 0 versus beta 1 not equal to 0. Let alpha equal 5. let me get something to drink here. It's right here. Okay. So it's just beta 1 equals 0. Versus B1 not equal to 0. Then the p-value you're going to get from over in the x row, go all the way over to the left. Sorry, to the right, I should say. And it's less than 2e to the minus 16. So I'm just going to put that. Well, and I'm going to say if p is less than alpha, then we reject HO. We reject HO. Okay. Okay, that was fun. Good job. All right. So let's take a look at problem 3. All right, how about patient satisfaction? If it was Mick Jagger, he'd say, we can't get no satisfaction. All right, but that would be too much fun. So we're going to say, let me check on here. How are we doing for time? It's not showing. That's weird. All right, patient anxiety. I think I'm going to stop this